looking at the James Webb Space Telescope as it moves gently away from its launch vehicle. Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth.
Yes, you're right, Rob. Impressive, fantastic pictures, yeah.
Now we'll be hearing shortly from the Mission Operations Manager at the Space Telescope Science Institute, Carl Starr, who will be calling out the procedures that will lead to the deployment of Webb's solar array. And down in the fishbowl where there is jubilation, let's go to Raphael Chevrier of Arianespace. And before we do that, Raphael, a bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for confirmation that it is power positive. And there it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl and Raphael Chevrier of Arianespace.
This is it. We have witnessed the confirmation that Ariane 5 have safely delivered Webb into space. The upper stage is now being placed on a safe escape orbit around the sun, but honestly, I've got to tell you that these images are absolutely incredible, and well, it may be the end of the mission for Arianespace, but it's only the beginning of the journey for Webb. It's now on its way to the Lagrange point. Congratulations to all the team involved in the flight. Really, there is no words to describe the immersion that is happening right now in the fishbowl. So all I can say is good luck, Webb, and bring us incredible data from the deep universe.
At that point, our sequence will continue.
Well, Raphael, congratulations on a perfect ride to orbit from the Ariane 5 out of Kourou here today. A view here in the Space Telescope Science Institute. Their work just beginning on a new era of scientific observations. Luce Fabregat, it was a smooth ride to orbit. Everything went by the book, almost like a simulation, without any problems. And we thank you for all of your insight throughout the course of the day.
We'll be coming back to Katie for the final phases of the countdown in just a little bit. So, I'm an astronomer, and this launch is a huge deal for me. I am personally really, really excited. But why is this such a big event for everyone? The Webb telescope is nothing less than humanity's next effort to move closer to understanding some of the biggest questions about the origin of our universe. And it's not just the origins of distant stars and galaxies, but it's the story of us, you and me, how we got here. And speaking of questions, we'd like to include yours in this historic event. On whatever platform you're watching our coverage, drop your questions with the hashtag AskNASA. Later in the broadcast, we'll answer some of them live on air. It can't be said enough that this is a mission for anyone who's ever looked up at the night sky and wonder. People all over the world are sending in their best wishes for the success of Webb. And let's look at some of them now.
제임스 웹 우주만환경 행운음입니다.
Boa sorte. Webকে অনেক অনেক শুভকামনা.
Veel succes, Webb.
بالتوفيق لويب.
Kongo inorimasu, Webb.
हार्दिक शुभकामनाएं।
We're still on track for a launch at 7:20 a.m. Eastern U.S. time. 2 days ago, the rocket rolled out to its launch pad in Kourou. Of course, there's already been a lot of activity at the launch site. Primary fueling procedures were completed early this morning, preparing the giant Ariane 5 rocket for flight. Let's watch the scene for a moment. We know the world is watching. Today, humanity begins its next bold adventure to extend ourselves out into the cosmos. This is something we do as a whole planet, all of us together. Befitting the global importance of this initiative, let's review some of the basic facts about the observatory shared by people all over the world who are looking forward to the Webb mission.
The entire world is looking forward to the launch of the James Webb Space Telescope. Let's hear more from a people around the globe about what makes Webb a scientific and technological marvel.
Será el próximo y principal observatorio espacial para los astrónomos de todo el mundo y llevará más allá los prometedores descubrimientos del telescopio espacial Hubble.
它是一个由美国国家航空航天局、欧洲空间局和加拿大空间局开展的国际合作项目。
Ni darubini kubwa zaidi kuwahi kuwekwa angani na ina nguvu mara 100 kuliko Hubble.
Webb is zo groot dat deze in origami-stijl moet worden opgevouwen om in de raket te passen. Om vervolgens in de ruimte als een transformer te worden uitgeklapt.
Les 5 couches de son écran solaire le protégeront du rayonnement infrarouge émis par le Soleil, la Terre et la Lune. C'est un peu comme avoir une crème solaire avec un FPS de 1 million.
अभूतपूर्व इंफ्रारेड सेंसिटिविटी के साथ ये पिछले 13.5 अरब साल तक के समय में बिग बैंग के बाद सबसे पहले पैदा हुई गैलेक्सियों को देखेगी.
در فاصله 1.5 میلیون کیلومتری از زمین به دور خورشید خواهد گشت، در حالی که تلسکوپ هابل در فاصله 560 کیلومتری زمین در مدار زمین قرار دارد.
Thousands of people all over the world have worked for years to get us to today's launch. The core partners, NASA, the European Space Agency, and the Canadian Space Agency are the principal players. But a vast core of engineers, scientists, private companies, and more have had a hand in building this one-of-a-kind scientific platform. Without a doubt, this is the most complex spacecraft ever built, with revolutionary technologies, daring mission goals, and a whole lot of personal passion and commitment. We'll hear from our partners later in the broadcast, but first, let's hear from someone representing the science community with a rare perspective about space exploration.
Hello, I'm ESA astronaut Matthias Maurer, currently living and working on the International Space Station ISS. I'm very excited to follow the James Webb Space Telescope's launch with you all from space. Even with the naked eye, we astronauts see that the stars are incredibly sharp and brilliant once we are outside the Earth's atmosphere. James Webb Space Telescope will be the largest and the most powerful telescope in space yet. And it was built to study the big questions. Questions like, where do we come from? How did galaxies form, like our Milky Way? How are stars and planets born, like the Sun and the Earth? Might there even be life on other planets? The James Webb Space Telescope is a joint project between NASA, the European and the Canadian space agencies, and by tens of thousands of people with origins in many countries. And it will be used by scientists everywhere on Earth.
NASA Goddard is the home of the Webb telescope, with big sections designed and built here. But actual mission operations take place here. This is the Mission Operations Center, or MOC, at the Space Telescope Science Institute in Baltimore. After launch, this facility will command and control Webb for the duration of the mission. We'll be looking at the mock at key moments throughout the broadcast, and this will become a familiar location for viewers in the weeks ahead as the Webb team begins to set up the telescope for work in space. So as we move closer to launch, we'll actually keep a picture of the launch facility right here on the screen. But for the next 10 minutes or so, we're going to talk about some of Webb's principal science goals. If you've ever seen a telescope before, I'm certain it didn't look like this. Of course, the look of this particular machine is a direct result of the scientific questions it's been built to pursue. So fortunately, we've got an expert pair of guests with me this morning to help explain those science goals and much more. So I'm joined now on the set by NASA's Deputy Project Scientist for Exoplanet Science, Nicole Colon, and also with Macarena Garcia-Marin, the Instrument and Calibration Scientist for Webb's mirroring instrument from the European Space Agency. So welcome to you both.
Thank you. Good morning.
Thank you. So this is our chance to kind of step back and talk about the science goals of Webb. You know, this is the part that really excites astronomers like all of us. And I know that there's unusual things about it being an infrared telescope. There are specific science goals, infrared answers. So maybe you could start us out, Nicole, with you're an expert on exoplanets. How is the infrared really important for your study?
Sure. Well, with exoplanets, we want to study their atmospheres. And as a reminder, exoplanets are planets that orbit distant stars. So we're looking for very small signals when we study their atmospheres. And Webb is this giant telescope that we're able to use to collect these small signals and look for infrared signatures, chemical signatures of water and methane and carbon dioxide, those types of molecules in their atmospheres. And why the infrared? You know, that's really because those signatures are the strongest in the infrared. We know that they exist there, and so that's why we want to use Webb to look there.
It seems an amazing idea. So exoplanets, planets around other stars, are light years away from us, tremendously distant. So how do we know if it's water, methane? I mean, how can we probe an atmosphere so far away?
Mm-hmm. Well, with Webb, there's a couple different ways, but one of the main ways is actually using the transit technique. And this is an indirect method where we actually detect the decrease in starlight that happens as a planet goes in front of its star. But then imagine the planet has an atmosphere. Well, there's an additional decrease in the starlight because the atmosphere blocks some light from our point of view. And why it blocks the light is because there's usually a molecule or something in there like water and methane, like I mentioned, that is acting as an absorber and blocking the light from our telescope, in this case, Webb.
So going from, you know, the relatively nearby stars and planets, Macarena, you're an expert on very distant things, distant galaxies. So how does infrared contribute to your field of study?
So with Webb, we're going to be able to observe the very first galaxies in the stars. We're talking about 3.5 billion years ago, so it's really mind-blowing if you think about it. And why infrared? Well, those galaxies emitted their visible light many, many millions of years ago, and that light travels towards us in time, and at the same time the universe expands. So in that process of travel and expansion, the light shifted from the visible to the infrared, and so Webb will be able to actually observe those very original primeval galaxies. And not only those, but it will also allow us to observe everything in between, so we can understand the evolution of our galaxies from the first ones to the ones we see today.
While the Webb telescope is a technological marvel, everything here began with questions. Questions about how the first stars and galaxies came to be. Questions about whether planets around other stars might have environments that can sustain life. And of course, the promise of discoveries we can't even predict yet. A few days ago, I had a chance to speak with someone who's probably the best person on Earth to help us understand what we know, what we don't know, and how Webb will help fill in those gaps. Dr. John Mather is a Nobel Prize winner who measured the Big Bang with an observatory built here at NASA Goddard. John is Webb's senior project scientist, and we're so pleased to have you here today, John.
Good to be here with you, Michelle.
So to start this incredible story of Webb, let's start with something that's deceptively simple, gravity. There's something special about gravity.
Gravity is special. Gravity always pulls. It's the only force of nature that always pulls. So that's special. And what makes that special is that gravity, although it's very weak, is very long range. It can reach across the universe and slow down the expansion of the material that came from the Big Bang, turn it around, pull it back together, turn it into galaxies and stars and eventually planets and a place where we could live. So that's what makes gravity special among all the forces of nature.
And something so simple, like just the idea that it's always pulling together, that simplicity leads to wonderful complexity, doesn't it?
Yes, because it's always pulling, it's possible for gravitational energy to be converted into kinetic energy, just heat, and the universe becomes self-heating, which is not something other forces could do all by themselves. Clouds of gas can be compressed by the gravity until they get big enough and hot enough to light up and have the nuclear reactions inside that turn hydrogen and helium into the chemical elements you see around you, here in the house, here on the set. So carbon, oxygen, nitrogen, everything we have that we think of as ordinary came from inside stars. So we are stardust, as Carl Sagan told us, but there wasn't any stardust in the Big Bang. So we need this part of the story to be figured out. How did we come to be able to live here on our little planet when the universe started out without all of these goody things?
So you mentioned these planets around other stars. So we're almost sort of going through all these amazing science goals of the Webb. What can Webb tell us about planets around other stars?
Well, once in a while, a planet goes in front of the star, and some of the starlight goes through the atmosphere of the planet, if it has an atmosphere, on its way to the telescope. We will spread out that light into a spectrum, or what you would call a rainbow, and we'll analyze it to see what are the chemicals that are in that atmosphere. So we will be able to tell you, maybe, that's the plan, whether those little planets that might be like Earth actually could have, for instance, water in their atmosphere, and maybe enough water so there could be a liquid ocean under that atmosphere. One of the great questions. So we know they're planets. We know when we should look. We just don't know what we're going to see.
So after the Webb launches, one of my dreams is I'm going to be standing outside in my backyard and point to a star and say there's a planet around that star that we know has water vapor, oxygen, perhaps methane, carbon dioxide. So what is Webb going to also do in the search for life closer to home, our own backyard?
Well, here in our own solar system, we will be looking at everything from Mars on outwards to the farthest we can see. Satellites, comets, asteroids, and the planets themselves. And some of them are really interesting and special because we know they're possible homes of life. What would make a thing a home of life? Well, if it's wet. That's the good clue. So the satellite Europa, which orbits around Jupiter, was discovered by Galileo himself, and we know now that it has an ocean that's covered with ice. There are cracks in the ice where water comes spitting out. NASA are going to send a probe over there to fly through those plumes. We're also going to point over there with the Webb telescope to see what can see about that atmosphere and those plumes of water. We'll be looking at Titan, which is a satellite of Saturn, which is so big that it has an atmosphere enough to fly a helicopter. And it is cold out there, so that what they have, what is on the surface, is solid ice, and over that are liquid hydrocarbons, which you would use for fuel here in our home. But over there, it's liquid rain, lakes and rivers, and we will be looking at the geology of that before we send the helicopter out there.
So you're on this amazing journey from the very distant early universe all the way to our own solar system, but this has also been a personal journey for you. You've been working on Webb since the very beginning of the mission, is that correct?
I have. Since '95, we had our first conversation, but people were even dreaming and imagining way before that what we needed. And you could tell even before we launched the Hubble what were the possibilities, and we learned that we would need an infrared telescope that could do things that Hubble could not do.
Well, John, I've been an admirer of yours for many decades now, and it's an honor to be with you on this part of the mission. So thank you so much for joining us. Best of luck on the launch and the mission ahead.
And thank you for asking all these great questions.
The Hubble Space Telescope delivered profound insights about our place in the cosmos. But perhaps the biggest takeaway from Hubble is that we've only just scratched the surface. Hubble gave us the best ever views of stars and planets forming inside vast, dark clouds of dust. But as soon as we had that data, we were asking new questions that needed better measurements, clearer images. Hubble was also able to capture images from galaxies so far away. Their light took 13 billion years to travel to us. These distant galaxies are just tiny dots in Hubble's images, tantalizing scientists with clues about how the first galaxies formed. In order to pursue a better understanding about the earliest days of the universe, we needed to build a better time machine, and that's Webb.